if there are any questions, I'll just kind of open it up for the delegates. What's on your mind? Just hear from you.
So there wasn't much discussion here. I mean, you mentioned the hybrid product, the QLC with PMem and stuff like that. You see, most of these deployments were all straight PMem, I assume. Is that correct? The ones that at least were using the Optane PMem I guess I'm trying to understand where the hybrid solution fits into this framework.
Okay, so yeah, that's a great question. Do we still have Dave Lindell on the line? I know he had another meeting he had to go to. If he's not here, I will muddle through that answer.
Or I can help with it too if he's not
here.
Okay,
hi, yeah. Yes.
So the hybrid product that we talked about, which is very much focused for our client market. So one of the things that we've learned is that because most people use their client machines in much more predictable, common ways, then setting the right ratio of how much Optane we need to do that right buffering and caching in front of a QLC memory is pretty standard. And so we've been able to then, because of kind of just how the homogeneous those workloads are, we were able to create a product that has a set ratio that meets almost everybody's need. In the enterprise space, which is a lot of what we talked about today in all these examples, the variation in workloads means that there are different ratios and different needs for how much of that Optane that you need in relationship to capacity. And a lot of the disaggregation, we also talked about, as we're disaggregating pools of storage, like sometimes you want them to be separate from each other, sometimes near each other. And so having one product that's a hybrid just doesn't lend itself particularly well to the enterprise space.
All right, so we're really talking mostly about the enterprise solution deployments here rather than the client solution. Okay, and when you say clients, you're talking about OEM, like big packagers of systems with PCs and laptops and things of that nature.
Yes.
Okay,
yes.
I got you. All right, thanks.
No problem.
Yeah, I was going to say it would also be interesting to see how PMem kind of works with your other products, like your FPGA family. Certainly from an ML and AI perspective, I mean, the ability to have fast storage and persistent memory is very important in AI and ML.
That's a great suggestion for a topic next time. Maybe we can tee that up.
So my question is more about the future. I don't even know how to frame it, but actually the idea is that we are seeing a lot of new trends at the edge. I mean, more compute, more everything, but actually very, very compressed in the size and the form factor and everything. Do you envision any future device where you get Intel Xeon and persistent memory together working in very small, very efficient devices at the edge for compute and storage integrated? I mean, it's since we are moving also GPUs to the edge now, or is it too early to think about this kind of devices? I'm not thinking about system on a chip, but actually an integrated system somehow.
Yeah, no, it is a great question. I would say that the way that we're looking at this is we're starting and making sure that we take down one use case and one solution at a time. But we are always evaluating where are we going to take this in the future? What are the other usages that we could pull in? And we actually have a small group that goes and looks at some of these opportunities. I think what is so exciting to me is that Intel touches so many of the different elements of compute at the edge, and compute in the data center, compute on the client. And as a portfolio of technology that we have to work with, and thinking about different ways we can combine, grow, change the market is really exciting. So we do spend time there. I will say it is a little early right now for us to get too far astray from, first let's get out there and make sure that we get all the databases and the servers of the world. But believe me, we are definitely looking to expand into new areas.
I might just add one thing to that, which is if you look at some of the those specs out in the community and the industry standards. One of the things that I see on the SSD side is moving off of add-in cards and U.2 to this E1.S form factor. And that's, to me, that's really about like, how do you get a form factor that's really condensing space-wise so you can pack, more in the same space and you can cool it correctly, which kind of lends itself to where you're going with like, how do I just compact this either to fit on a card or in a box for those more edge deployments.
Yeah, I find what you're doing, like the Cerner case study was a fantastic example of how you're going out and approaching edge. But I also know how far Intel can push at edge. I think I've got one of the development samples of the Intel compute card over here, which has full, NVMe based storage in it. I'm curious to just know, are there, how far are you willing to push the edge? Because I think there's some other opportunities that really could present themselves for this level of storage, this level of analytics, because the amount of analytics being generated at edge is going to be exponential next year compared to where it is now. And I think this is a really good opportunity for you to take advantage of that. I'd like to know if you got any plans to pursue, like Enrico was kind of saying, taking it down even further.
Yeah, we are looking long term. We see the trend at the edge. We know that there is an opportunity to play there, and to best figure out how quickly we can transition and what we come up with is the real question. So, thanks for providing that feedback, and we are on it. I know that there are some discussions with part of Intel ICAP to look at, are there other partnerships or companies that we could work with to expand? We don't have to do this all ourselves. And we're also looking at alternative business models for the technology. So that, I think that was one of the earlier questions somebody said, is it always going to be just Intel? There are lots of ways that we could play in some of those edge markets.
Yeah, and Kristie, if I can add, I think the other thing that we are also doing more broadly is also engaging through the partnerships that we do have, right? Like we have deep partnership with SAP. And so we look at the portfolio that Intel brings and the portfolio that SAP brings and kind of trying to see synergies as well. So it's sort of, because of the relationships that we do have with the ecosystem, we're also getting, tighter and more integrated with what our partners are seeing and where they see demand.
Yeah, that's a great comment, Vishal.
So one question on the 3DX crosspoint. It doesn't seem like you guys are advancing the density as much as we're seeing with the NAND space and stuff like that. It's not like, I don't know what the number of layers is of the current chips, but it looks like it was a 3-layer chip or something like that, or at least two data layers in that environment. As with TLC and QLC going to, 100 layers or more. Do you see?
No. Yeah, that's it.
Are we seeing the 3DX going vertical, I guess is the question.
Yeah, great question. The answer is yes. We just came out with our 4-deck media just this last year. And I think the question of advancing it is it's much easier for us to do that than you would think. And we're not yet seeing the market demand for it to be denser. We are having a hard time getting customers to consume at what that would mean if we doubled our density. And then there always are technical challenges. But I think what we're doing is we're keeping a very tight eye, or a very close eye, on what the customers are needing, what the demand is, and scaling appropriately for the investment in the new media. But yeah, were you aware, Ray, that we did just release the 4-deck?
No, I guess not, but that's good. But yeah, my guess is it's almost like, build the field and they'll come. If you had double the density in Optane SSDs and double the density in PMEMs and the servers that supported it, you don't think there would be demand there? I guess, I don't know.
Well, I'll answer for PMem, then I think I'll ask Allison to look at SSD. I think, for PMem, we actually tried the experiment. We've had a 1 terabyte on our, planned roadmap for a long time. And each time we come back and we're still seeing very low connect rates on the highest density DIMMs. There's a cost factor that goes into that. But until we have customers that are saying, I need it, I want it, we aren't going into the higher capacity. It's not because we couldn't. The media it's quite capable of doing that, especially with the 4-decker. Now the answer might be different for you on SSDs, Allison.
Yeah, I think maybe one thing to know. So our SSDs today we have up to 1.6 terabytes, and we have a plan later this year just to do a 3.2 terabyte. But even out of what we're shipping today, I mean, the highest volume really goes to our smaller size, our 375 or our 400. And I will tell you, because of my experience on the NAND side as well, is that while you can buy very, very large NAND SSDs, almost all of the NAND SSDs out there, they start saturating, their read performance or their backend performance against the bus at 2 terabytes, 4 terabytes. And so even though there is all this doubling and much larger capacity, the problem is that you end up with like more gigabytes of capacity than what you need for the performance. And so, NAND, we're having trouble even with the NAND and really fully utilizing all of that.
I was hoping as you doubled capacity, you'd have the price per gigabyte or something like that, and that would start driving more capacity consumption and larger consumptions.
Yeah. I think it goes to this, like, and one of the reasons why Optane uses this is like there's more. If you think about like as we put more density on the NAND die, what happens is to get the same performance. So like say last generation's 2 terabyte drive, say I want to match the performance. Now I'm buying an 8 terabyte drive to match that performance. And at some point I have more than I need.
But doesn't that just drive more PCIe lanes and PCIe 5 and PCIe 6 and all these things start to come together because you've got the demand out there? I don't know. I'm not sure if that's the right place to go, but it seems to me that doubling every 16.
I mean, the doubling. I will say, especially from a very Optane-centric view, the doubling is really good because as you're doubling, especially like usually the performance characteristics of the media don't always keep up directly, and so you're widening that gap, which gives a really good place for Optane to come in and fill some of that I/O.
I got you.
I remember too, like you guys were talking about when we did the event last month that QLC is getting bigger, but at the same time QLC has been getting bigger, it's getting slower.
Correct.
IOPS per gigabyte is dropping. Yeah.
Yeah. So there has got to be this kind of now. I'm sure what you're thinking is this in between component. And I think that kind of helps. Like Ray, kind of what you're asking, yeah, it's getting bigger, but at the same time, every time you're adding a layer to that cell, it's getting slower in the overall.
No, it doesn't get slower. I don't think you're adding layers will make it slower. It's the challenge is how much performance can you get out of that NAND die is getting to a point where it's over consuming the performance available in the server, I guess. Is that what you're saying, people, Intel?
Yeah.
Yeah, it's that balance of the back end with how much performance you have on those PCIe lanes.
Mm-hmm. And then I would also add that customers are very savvy. They aren't going to, if they don't need the capacity, they're not going to buy it. And so what we have to do is match where the capacity is needed. We know it grows over time, but just making it doesn't generate the demand.
Yeah, but obviously you have to bring value to the equation that says this capacity is going to give you more benefit. And, having the performance scale linearly with the capacity is going to be an important consideration for Optane from now on.
Mm-hmm. Mm-hmm.
So last month as well at the event, we saw the introduction of the second generation of PMem product. And I'm curious, what applications couldn't be done with the first generation PMem that the second generation opens up?
So the second generation, there's a few key features. I think we talked about EADR. There are some other items. I think it's not a big change between the first generation and second generation of PMem. It's going to be the third generation that really is the step forward. And so what you're getting out of the second generation primarily is the performance at lower power. I will say the one thing that we learned, to keep reminding you guys, it's a learning journey. The power consumption is actually highly valued if you can reduce it. And we got a lot of feedback from the hyperscalers in the first generation that if we could improve that, that would help. And so we, on average, dropped about 3 watts per DIMM to get to, and we're still getting 25% more performance or bandwidth. So that's really the primary change with second gen, and you'd have to stay tuned for the third gen because that's where you'll start seeing some different features. Where we're continuing to bring value, though, is to continue to bring on new ISV partners and OEM partners, so that these reference architectures or databases make that software or that app direct enablement seamless. So that's kind of in a nutshell.
Are there any specific ISVs or IHVs that you are targeting that you would like to see as an ideal candidate for this?
Oh, always. There's a long list. Allison is part of our solutions group. Maybe you can. I can. A few of them that I'm listing right now. Hazelcast, Nutanix is a new one that we're adding for persistent memory. We are working with Memverge. They are showing remarkable promise in the industry. There's a long list. Yeah. What about you?
I'll just note that they're a Tech Field Day company, and if you'd like to learn what she's talking about, we've got some great videos of that.
And I would like to actually push this one step further and say, are there any startups that don't exist yet that are in a realm that you think this would be a good fit for?
Oh, if a startup doesn't exist yet, I don't know if I could identify them, but
I'm looking for my next idea, by the way.
Yeah, for sure. I would say Memverge fit in that category because when they first came across my desk, they didn't have a product. And we started working with them and with their proposal, their ideas, they took the software that they had and they improved it. And all of a sudden, the way I view it in a simplified view is they do the app direct enablement so that the customer doesn't have to. They provide virtualized pools of memory, and then they provide storage at memory speeds through this activity. So those 3 things, that's the value prop they bring. And oh my goodness, that's going to be like the secret sauce, I think, for helping ease of adoption. We're seeing actually financial services companies are starting to adopt. And so for me, that's a key ISV this next year. I think the list is different for Allison.
I'm sure. We've seen some interesting use cases for Optane persistent memory, also on the storage side, but in different sort of categories than for example, the way VAST is doing it. One of the use cases that I think is interesting is how Pure Storage has leveraged it in between the infrastructure, the fabric, and the storage itself as a cache buffer, so that in effort limiting or diminishing the number of microseconds between the compute layer and the storage by at least half. Is a very interesting use case, particularly for high transaction databases.
Yeah, and I think just to add to that, that is one of the most interesting use cases that we're really seeing with even more of our customers than Pure. But it's the same idea. It's just like as you're starting to separate and pool your compute and your storage together in that disaggregation, it's a very powerful write buffer. To just help you make sure that you get the data to the right place and then process it once it gets there.
Right. I like the Pure Storage use case better because it makes storage much faster, whereas PMem makes memory much faster and affordable.
I don't want to step on Jason's toes, but I think the creativity that we're seeing, that how these products enable the different industries to leverage sort of a new creative approach towards how some of these problems exist and need to be solved is really where I find everything reaching inflection. It's very interesting.
I think VAST is a prime example of that. What Intel did with the creation of this technology is you gave a new paintbrush to the startups that had a very creative idea. And that's so you're adding tools to that palette is beautiful.
Nice analogy. Thank you.
Yeah, that's really well said. And I think that that kind of sums up the Intel strategy for the last, 40 years. I mean, is to do things like that.